Our planet is an inside-out spaceship, alive in the cosmic desert. Perhaps just in time, we can perceive it as a single system. Satellites that circle the living Earth can watch over it as never before. Combined with modern computing power, space technology is helping scientists to create a new global geography. Its aim is to find out how Spaceship Earth's life support system really works, and how natural and human forces are really changing it.
2, 1.
Ariane rocket launches the European Space Agency's remote sensing satellite, crammed with radars for examining the oceans. Other spacecraft watch the weather hour by hour, day by day, across thousands of kilometers, while the French satellite Spot inspects the land in detail. The western tip of France. Barcelona in Spain. The narrow throat of the Mediterranean Sea. In strips about 60 kilometers wide, Spot patiently scans the whole world. The various satellites send their images as radio signals to ground stations. They reveal the rapid shifts in the weather or other slower changes at the Earth's surface. You can't build a house in Washington, D.C. without the Spot satellite noticing. It can see objects as little as 10 meters wide. And Spot visits New Orleans as regularly as Paris. Like the satellites, this series sees Spaceship Earth as a global system of air, water, and rocks supporting life. But it also homes into ground level to see how human beings interact with the system. Java in Indonesia. Its inhabitants rely on rainfall to water their crops. But the weather's a global machine, and so is the geological machinery that builds the very ground of Java. A watchtower in a village close to a volcano. A worldwide system of mobile plates determines where the Earth's crust will erupt. Java is in the front line. Mount Merapi throws out millions of tons of dust and rubble in frequent eruptions. The smoke is menacing. But volcanic debris breaks down into excellent soil, and farmers hungry for land crowd around Merapi. One day, they may have to run for their lives. Satellites watch the volcano too. Geographers in Java use an image from space to study Merapi's most recent outpourings. The view from the sky helps them to identify danger zones. They highlight the flows down the volcano's flank in red. They take out unwanted coloring to expose the landforms that will guide the future flows. Satellites watch nature's volcanoes altering the face of the Earth, even in uninhabited places. But they also monitor changes due to human action. Africa. The film camera finds a family of shepherds returning home at sunset with their flock. It's the dry season here in Kenya, but even so, there's too much dust. The land's in trouble. The animals have nibbled the vegetation until there's not enough left to bind the soil. The wind blows it away. In an image from the American Landsat spacecraft, the colors are false, but red patches denote vegetation. Gray patches near the lake look barren, and a view from the air confirms it. United Nations experts believe that satellites will pick out degraded land anywhere. Here, wind and water have swept the topsoil into the nearby lake. A normal lake looks black to the satellite. But Lake Baringo, thick with soil, reflects more light, identified here by a false blue color. Look at the globe again. The land masses are quite small. The oceans cover 7/10 of the Earth, and satellites now scan them more thoroughly than ships ever could. In the tropical Pacific, only small island groups interrupt the ocean's broad expanse. On a fine day, Samoa can seem a paradise. By absorbing the sun's rays and by evaporating water, the tropical ocean drives the whole world's weather. Today, it's working peacefully, but it's not always like this. Vigorous evaporation caught up with the Earth's rotation can spin up the hurricanes that sailors dread, with good reason. The wind draws its energy from water vapor sucked from the warm sea. It's nature on the rampage again, and the Samoans count the cost. A cathedral, built and decorated by their own hands, has been wrecked by the storm. The hurricane dug up the bones of their ancestors from a graveyard. It uprooted many palms. And even while the weather station on Western Samoa was reporting on the storm, one of its own buildings was blown away. But broadcast warnings come in good time these days because hurricanes are obvious from space. Satellites can track their movements and reveal their structure. The streaks made by the wind spiraling into the dark eye of the hurricane become plain in a repeated sequence. For 30 years, the United States has led the way in observing the Earth from space. Military needs in the Cold War stimulated the technology. Nowadays, manned flights are routine, even for launching unmanned satellites. From the space shuttle, ordinary cameras have spectacular views of Spaceship Earth. Yet they're strangely uninformative. Invisible rays can enrich the images, as when infrared sensors over Europe help to pick out vegetation. Many space observations went into this cloud-free image of Europe. Here, vegetation appears green, but it's coded red in this image of the United States. A forest fire in California seen from an American weather satellite. Every night on television, Americans watch pictures from space of the moving weather. When great bubbles of clouds form over the Midwest, tornado warnings go out. A special boost to global geography comes from seeing the entire world from space. NASA's Goddard Space Flight Center near Washington, D.C. made a breakthrough in using signals from weather satellites to assess vegetation across every continent. Compton J. Tucker compares visible and infrared measurements from the land surface to deduce the vigor of plant growth. Here, purple is the most flourishing, and the passing seasons alter the picture. Tucker can look anywhere, any year, any month. In Africa, the Sahara Desert at the top stays barren. Space images like these now serve routinely to predict famines in the drought-prone belt south of the Sahara. North America in different colors. A sequence of images shows plants activated in summer and then resting. Let's see it again. Winter, spring, summer with maximum growth in blue, and autumn. During the Cold War, the USA watched Soviet harvests from space. Here, the Soviet Union is on the right. Nowadays, Goddard's amazing images portray the Earth's systems at work. The Amazon forest. The deep blue means wet soil, registered by a satellite that measures radio microwaves. In North America, the soil of northern Canada is relatively dry. When satellites can measure the soil moisture across broad areas and see plants reacting to changes in daylight, scientists can discover how vegetation and climate mesh together. So a Goddard team masterminded an experiment called FIFE. In the heart of the USA, in Kansas, they chose an area already under study by Kansas State University. At the Konza Prairie Reserve, the bison are back, though not the millions that were here before Buffalo Bill and other hunters massacred them. And it's still cowboy country. This patch of prairie is too stony for farmers. The Fife experiment put the prairie under intense scrutiny as scientists pitted bold new theories against observations from space and near the ground. The experimental area was 15 kilometers wide. A springtime image from the Spot satellite shows much of the area blackened by fire. Smoke is still rising from the Konza Prairie, where the scientists regularly burn the grass, just as the ranchers do, and just as the American Indians did centuries ago. Without frequent burning, this prairie would be woodland. The fires turned this piece of the biosphere, the Earth's living surface, into the Indians' happy hunting ground. And the prairie interacts with the lower air, the troposphere, as Piers Sellers from NASA explains.
In a couple of months, this prairie will be completely green. All the grass will be about 2 foot high, there'll be flowers everywhere, all the bushes will be covered in leaves. And at this point, this whole area will be sucking down carbon dioxide from the atmosphere and evaporating water back into the lower boundary layer, more or less where the rubber meets the road, where the ground surface interacts with the troposphere.
The Fife experiment ran in 1987 and 89. Scientists examined the prairie and its atmosphere at ground level and with airborne instruments. They were all watching the grass grow, watching it use daylight, moisture, and carbon dioxide to drive the natural chemistry of photosynthesis, upon which the life of the planet depends. And the air and the climate interact with the busy grass.
The center of the experiment, the Fife experiment, was really how to translate our understanding of the biological processes that govern photosynthesis, the drawdown of carbon dioxide from the atmosphere, and evaporation, that is the slurping up of water from the root system, out through the plant into the atmosphere. How these processes, which we understand well in a laboratory or in a single plant, how they work on a huge scale.
The ground teams, the helicopters, and the planes all measured the same features of the prairie at a widening scale. In this case, the temperature of the ground by infrared rays. The dark areas are cooler. A laser beam swept over the prairie and detected puffs of warm, moist air rising from it. They're the shaded red areas in this display. More intimate views of the living grass came from scanners, like this.
So with these instruments, we're looking at a range of scales, really, from the individual plant up to 10 square miles at photosynthesis and evaporation. But that's just part of the story. The other half is, what do those processes look like from space?
The red color in a Landsat image represents vegetation reflecting infrared rays while absorbing the visible light. Out of season, the color's muted, as in this aerial image. When the grass grabs visible light to grow by, the color deepens. Lack of water can limit the growth of grass. While microwave sensors in the sky detected soil moisture, direct measurements on the ground checked those observations. In a microwave image from an aircraft, white is the wettest soil, just after heavy rain. 2 days later, the prairie was losing moisture, and within a week, the dry soil, coded orange, was widespread.
The final goal is to do biology from space, all the time with the same set of instruments. If we do this, we can get a handle on how changes in the Earth's atmosphere and climate system might interact with the biosphere to ameliorate or worsen global change.
For many scientists, global change is now the name of the game. Change due to nature, change due to human action. But sorting out which is which requires geographical insight. In Central Asia, for example, who's to blame for the notorious Karakum Desert? The oasis city of Bukhara has been a gateway to the desert for 2,000 years. Traders with Chinese silk passed this way, bound for Europe. Muslim armies introduced Islam, and it's still the prevailing religion. By ancient tradition, the people of Central Asia are herders who graze their animals in a dry land. They were fierce warriors too, until the Russian army subdued them 100 years ago. After the Russian Revolution, they became Soviet citizens. But everyone's enemy is the all-conquering mobile sand. Poor rainfall leaves the surface dry. Yet plants can drive roots deep into the sand and find water lurking there. The Karakum Desert is far from dead. There's even food for grazing. Given a chance, the plants can bind the sand, as the saxaul trees do that grow in clumps among the dunes. Patient plants wait for a shower of rain to turn them green. But if the plants lose their grip, perhaps because of human activities, the wind can set the sand moving. Its surface becomes barren. To prevent the dunes overwhelming villages and roads, networks of low fences can check the mobile sand. And for deeper understanding of deserts, the geographers turn to images from Soviet satellites. Like great waves in seas of sand, the dunes dominate some desert regions, but others, with less sand, show dark rocky outcrops. White dry beds of temporary streams are visible too. Here, a region of dunes gives way to a belt where plants have subdued the sand, creating a broad green area of grazing land. But overgrazing by the herds creates white dots in this space image. Each of them surrounds a well used for watering the herds. And here, farmers have begun to tame the desert. At the top of the image is a patchwork of irrigated fields. The Soviet border, with Iran on the left, stands out in brown and red in this desert scene. Vegetation flourishes in the border strip because grazing herds are banned. Images from space can't cure the overgrazing and firewood gathering which make deserts worse than nature intended, but they put the issues on show for all the world to see. The satellites fly freely over difficult terrain that hampers exploration. In the far south is the harshest continent of all, Antarctica. Since the discovery of Antarctica less than 200 years ago, explorers and scientists have risked their lives to penetrate the mysteries of the frozen continent. But the satellites have laid its ice sheets and mountains bare. In this image, assembled from US weather satellite data by British scientists, the reddish streaks are giant glaciers. The Weddell Sea, where the British Antarctic Survey has a base at Halley Bay. For many years, it's gauged the layer of ozone high in the atmosphere by measuring the ozone's power to absorb dangerous rays from the sun. Joe Farman discovered that the ozone over Antarctica was diminishing from year to year. When he reported it, American space scientists looked back over their records and made space images of the ozone layer. Antarctica's towards the bottom. A wide region of low ozone became apparent, colored purple. the ozone hole. Farman's findings became headline news.
In 1985, his results were published, and we at Goddard were working with the Nimbus 7 total ozone mapping spectrometer, and we were able to confirm his results, and we were able to map the ozone hole quite extensively.
Animated satellite views, with Antarctica now in the middle, show the ozone hole colored mauve and growing. The spectacular images from space helped to stir international action against the man-made chemicals thought to cause the loss of ozone.
Since then, we've been able to use the satellite data in other ways to understand the process forming the ozone hole, including the polar vortex and the wind structure, which comes from the meteorological satellite system. Okay, here you can see that the ozone depletion region is mostly overlaying the Antarctic continent, with the higher ozone region ringing it. Now comes the atmospheric. Well, let's rotate the image upward now and take a look and see what's going on underneath the vortex. Now you can see behind, underneath the vortex region, how the ozone depletion extends underneath, about out to the region where the maximum wind speed is. It's interesting that the highest ozone region here corresponds also to a zone of maximum wind speed as well.
In the world's weather machine, Antarctica is the main refrigerator. Here, a computer manipulates the space image to simulate a flight over the ice sheets. A puzzle for the new global geography is how do all the pieces of Spaceship Earth's life support system work together? This series will compare the global view with local circumstance, the natural forces with human action. If we know rivers better, will we use them more wisely? While satellites assess the patchwork fields where people grow their crops, can they also judge the assault on the world's forests? The big computers say we are changing the global climate. Yet the machinations of the oceans and of commonplace clouds confuse the forecasters. And when nature works its geological changes, the ground shakes and puts great cities in danger. Human beings have always meddled with their planet, though never as busily as now, with lights blazing out into the night sky and human numbers set to double. It's high time to see people everywhere as just one crew of Spaceship Earth. Meanwhile, most people are still very poor. How can the crew look after the spaceship if no one looks after the crew?